Okay, there we go. Well, hello everyone for our Vibe Tuesdays event here with our special guest, Alec James. Say hello there, Alec. We're going to explore the wonders of ZK, the wonders of what Nexus is building for building this supercomputer that is super cool, and even the applications for AI, decentralized AI there. It's going to be great. Just bear with me for 2 minutes as I explain the whole structure of what we're doing. We would like to announce for everyone here, everyone listening to the series of videos later, that we finally reached 17,000 of sponsorship collected for our fund. All of this money is going to go directly for the fund, for the projects curated. So if you didn't already, submit your project here. We have 17 days left for submission. I'm going to announce that today in the public channels too, for you to put your projects there, get votes, and I'm loving the quality of the submissions. Real projects that are getting some real revenue. I'm loving the idea. We had a sponsor confirmed for the Vibathon, so it's real. It's going to happen. I'm going to announce that very soon too. And not only money, not only the financial contribution, but we're going to support you with all of the toolings and knowledge needed. So if you haven't already, check our event calendar. Come to this link in the fund page. Check our event calendar. Why isn't the link working? So check all of the great guests that we're bringing. Alec James is going to speak about building with the ZK, blockchain, Web3, and AI for you to vibe code with these stacks. And also check on the future content that we're going to have. MCP servers with Patrick Skinner. We are going to have legend Austin Griffith. You heard about the scaffolded, right? Now we're going to hear from him directly, Naruto, and more to come, leading to a Vibathon that is going to be announced. So make sure to subscribe here as builder, supporter, maybe even a sponsor if you can, and let's make part of this community. I want to see what you all are going to build with this tech. Maybe you're going to deploy soon on Nexus. Maybe you're going to join testnet 2, testnet 3. Don't know, Alec. You're going to speak more about that today, right? And let's see what kind of startup vibe projects you can get together for submitting to that fund.
Awesome.
Alec, now tell me a bit of what you are building and what the public can use Nexus for.
Well, what a wonderful intro, Matheus. Thank you very much. Very happy to be here. I have a little presentation. I think it's a good question that you raised that I'd like to come back to after this presentation. So I'm going to share my screen a bit and just give some intro and context into Nexus, what zero knowledge proofs are, what the technology underpinning our software suite is, and then we will get into the applications and also how you can sort of make it easier to build for yourself on our network and with our zero knowledge virtual machines. So just give me a minute while I figure out how to screen share. It always takes a minute, doesn't it?
Yeah, that's always true. We have been doing that a while, vibe coding, like you ask the AI something and then you wait. We need to put some background music for next events.
Okay. There we go. Awesome. So Nexus, this is our logo, the hypercube. So remember that. But as I mentioned, we'll go through mission, bit of ZK, our products and services, the team, and then how you can get involved. So on the mission, we are setting off to build and enable the verifiable internet. And really what that is an internet where you have trust, efficiency, and scalability built in at sort of the universal level. Right now, whether you are interacting with a website, program, downloading a file, set of data, whether you are interacting with socially online and want to sort of, for example, interact with some individual who has promised they have done some computation or done some work on your behalf, you really have to trust in a social context that is true, right? And I think human society has grown and flourished out of all, in the animal kingdom because of our social dynamics and the ability to trust each other. But unfortunately, there does come a point in a scaling of society where it actually becomes more profitable, high expected value for individuals to not be truthful, right? To be dishonest and distrustful and that kind of thing. And they went out from that. And so, at the size and scope and interconnectedness of the world right now, we see a lot of that, right? But the internet has brought a lot of positive benefits to the world, to society, to civilization. And how do we improve it? And how do we improve its ability to help coordinate interactions across space and time between humans? We at Nexus know that the answer is rooted in cryptography, which underpins Bitcoin, one of the, objectively safest assets. Currently, it does fluctuate for a number of reasons, but objectively safest. And this is what we're trying to bring, that kind of asset security is what we're trying to bring to all of your interactions across the internet. So just think of Bitcoin's primitives applied to the internet, and that's really the foundation where we want to start. But that's our mission, to enable the verifiable internet. We are doing that by building a global and world supercomputer using the latest advancements in cryptography and computer science. And effectively, what this supercomputer will do is to allow the verifiable computation of any program across the entire internet, across the entire world. This may sort of remind you of Ethereum's original mission, which is and vision to be the world computer. And we are taking this a step further to be the world's supercomputer. And super comes in from the zero knowledge technology that underpins the network we're building, which really makes it even more powerful as more nodes and more entities provide computation to the network. Ethereum itself and other blockchains do not have that capability. They get slower by the nature of their design for adding more nodes and more validators and increasing that decentralization and computation capacity. We go the opposite way. We get even more powerful. We've raised about 25 million Series A from top investors. Our team was sort of emerged out of Stanford's cryptography department. And that's why we feel we are in the best position to make this a reality. So zero knowledge, if you've been in the crypto space, you may have heard this been thrown around a lot. It's one of my favorite concepts from first coming into the space around 2.5 years ago. But I'll do a quick deep dive into what this is and how it works. I'm not sure of the knowledge base of the audience here, but I'll try and
imagine we are attracting a lot of people that never even coded before. Some
okay.
Coded, but they are listening to this soap of letters for the first time, and they are finding it delicious. Let's
wonderful. Well, I think for non-coders, this is the coolest coding thing that exists aside from AI. Personally, as a non-developer myself, but a capable person, obviously. So what is ZK? ZK stands for zero knowledge, and it's usually a zero knowledge proof. So zero knowledge cryptography, again, cryptography is what underpins a lot of computation, a lot of how the internet works. Zero knowledge cryptography allows an individual or a program or a business, an entity, to basically demonstrate that they have some piece of information without actually revealing what that information is. It's almost like digital magic. You can basically say, I like to make the analogy of, say you're going to a bar or a restaurant and you're asked to prove your ID to order an alcoholic drink. You can effectively prove to someone that you are over the age of 21 in the US or 18 elsewhere without showing them any information about your birth date, your address, your name, anything. And so I think in the modern world, we've lost a lot of the principles and respect for privacy and data security. And we sort of are in this comfortable zone where it doesn't really affect us too much, but we are also losing out on a lot from giving up our data willingly to a lot of these tech companies. Zero knowledge proofs sort of protect people while still being efficient. So they really have three properties, as you can see in sort of the definitions and principles. The first is they enable proving without revealing the secret, and in a complete way. So you can completely trust that a provider of this proof has the information that's required and can convince the sort of checker, the bouncer, the verifier without even needing to give that information. So zero knowledge proofs are complete. They are sound, which means there's almost no ability whatsoever for the person submitting the information to lie and be dishonest. And finally, there's zero knowledge, which again means no information about the information, no data about the information you're trying to provide will be revealed. So completeness, soundness, and zero knowledge, those are the three main characteristics of zero knowledge-based cryptography. And again, it's all about demonstrating knowledge of a secret or some piece of information without actually disclosing that, which is really quite powerful if you think about it. And it's all based on math, which again is super interesting. I was not a developer or sort of, what would I say? I was not a mathematician in college, but it's very exciting to start to understand how things like this are possible. And it's all based on cryptography from the likes of Alan Turing, dating all the way back to sort of coding and decoding messages from world wars, right? So zero knowledge proofs, so they have programmatic implementation here, which means you effectively design a program where you then put a piece of information or a computation into this program. It does some mathematical magic to it, and it outputs a proof that doesn't reveal anything, but can be used to verify that you have that information. I think an important point to note is that this proves both information, so like your birth date, but also computation. So it also would, for example, if you wanted to pay someone online to send your significant other a lovely message, how do you ensure that they have done that without getting your significant other to send you a screenshot or something? Well, you can sort of prove the sending of the message. I'm not sure if that was a good analogy, but I basically just want to emphasize that you can either prove data or prove that you have carried out some action online, i.e. computation. And so again, yeah, go ahead.
And just to add a little spice to this theme, we just had the Google releasing, like ZK was a nerd thing until last week. Now it's everyone, all the influencers are speaking about, because Google is adding that to their wallets and now became a trend again, right? And you guys were doing that before it was cool, like the hipster.
It's a big deal. So Google basically just announced that they're integrating zero knowledge proofs into their wallet to help supplement identity. And zero knowledge proofs are great at digital identity because, again, you have sort of complete ownership of the information that makes up your identity, and you can selectively, you don't even have to reveal anything, but you can selectively prove different aspects of your identity without actually revealing anything. So truly beneficial in a lot of ways, and I'm very excited that Google has done that, and we are excited to look to work with them going forward, and any other big players like that. But yes, just to wrap up this slide, what is ZK? Most ZK, there are a couple different ZK schemes. One is ZK Snark, and then the other is ZK Stark with a T. And this really stands for zero knowledge, succinct, non-interactive argument of knowledge. And that logically sort of means what a ZK proof is. It's succinct, it's compact, it compresses information and interaction online. It's non-interactive. You don't need to interact with the actual information itself. You just interact with a proof, i.e. some kind of secret derivative of the information. And argument of knowledge, again, sort of speaks to the application of zero knowledge proof. You want to argue that you possess knowledge, but do not want to reveal that. And I think that's really cool. There are several different components that I won't get too deep into, but there is a prover that is the individual sort of submitting information. There is a trusted setup, which is for any codes used in World War II or whatever, or in any wars, you always have some kind of key to encode and decode a code. And there's an equivalent version of that for zero knowledge proofs. It's called a trusted setup environment with public parameters. And there are sort of innovations happening in the ZK space to remove the need to even have public parameters. But that is the case. And the most complex thing is these things called arithmetic circuits, where you sort of break down a statement of data or a statement of a computation into arithmetic sort of polynomial functions, basically that represent sequentially the data or information in a truly sort of reductionist mathematical way. And that is it's a series of functions that translate the data into this final proof in a similar way, but also very dissimilar to how hashes work for Bitcoin. So you can put any information into a SHA-256 hash, and any information will output sort of a string of the same length. And you can input any amount of information, and it'll always output a string of letters and numbers of this set length. And that's really what this polynomial sort of circuit system does. And then you would get a proof. You send that to the verifier. The verifier uses the trusted setup with the public parameters to like decode this without actually decoding the information. Please feel free to ask any questions in the chat as well. That's about as deep as I'll go in terms of the technicality. Again, just to keep this going. But yeah, these circuit things really what's underpinning all these zero knowledge proofs. And again, it's like a program. You run information or a computational program through another program to encode it in this way. So what is it used for? Secure authentication. So, proving any information in a way that doesn't leak any of that information. So like high confidential computing in any large corporate entities or public entities, right? Governments, defense, anything like that. They, for example, DARPA in the US, they have their own zero knowledge virtual machine projects that they have been developing to carry out their internal program executions without any risk of hacking. And they're also very useful in blockchains for expanding on the application development capabilities as well as privacy of blockchains. As some of you may know, blockchains are like semi-anonymous, right? They are largely private as well. They're not even private. They're anonymous as long as you cannot track the on-ramp and off-ramp to the address, but they actually aren't private at all because you can see exactly which address interacts with what protocols and transfers which money, which isn't really private. There are some zero knowledge based blockchains which basically batch up a lot of these interactions into a single proof, whereby you cannot sort of decode who is sending what and which assets are moving between which entities. And that is one of the benefits of zero knowledge proofs. But overall, they enhance privacy, security, and trustlessness or verifiability. So again, trying to remove the need to even have trust, which I'm extremely bullish on because, imagine how efficient the world would be if you could sort of execute or interact with someone across the world and not have to worry about trusting if they will complete the task or use the data in the way that you envision. So I think that would just be net positive for everyone. Again, feel free to hit me with any questions. For these applications, I'm going to start fairly high level. There are a lot of very specific applications you can get into. One of the benefits of this technology is it can be applied to any industry and really used for any use case, which sort of makes it good and bad. But overall here, a big opportunity is in verifiable decentralized networks. These are blockchains and other sort of coordination and storage mechanisms that are distributed. With a lot of blockchains like Bitcoin, and even sort of Ethereum, they're very limited in the applications that can run on them. Bitcoin can't have any applications, and Ethereum, it costs, I think, $1 million to upload a gigabyte of data onto the system or something, or to have a very expansive program set. There's thousands and thousands of lines of code. It becomes very expensive, and that's why you see a lot of roll-ups and layer 2s being developed, where they sort of develop an entire new blockchain that is settled into just a few blocks on the original blockchain, and it's sort of a compression mechanism. But zero-knowledge proofs here would allow on any blockchain you to perform any computation from any program and input any data in a way that does not sacrifice the consensus, decentralization, security, and ideally privacy, which is why people use blockchains, right? The reason that so many people and so much capital across the world has interacted and sort of moved to these decentralized networks is because they're these, completely fair interaction grounds, right? You have new kinds of actors who are sort of like middlemen, like scraping off margins over your interactions, but they're a lot less influential than you do have in the traditional financial sector, or even, for example, transferring money through Western Union across the world. I've seen statistics where they take as much as 40% of the money you're sending in remittances. With blockchains, it's as much as, I think, a couple cents or something. But zero-knowledge proofs, when integrated into these networks, allow you to bring on even more complex apps. Like, again, the goal of Nexus is to enable the verifiable internet, and you currently can't build most, if not all, of the applications that exist on the internet we know on like Ethereum, for example. So we are stepping in to use both our zero-knowledge proof-based system and a blockchain that I will get to sort of solve that issue. But yes, and privacy again. So privacy, improving security, and improving the scalability, I suppose. So bringing new applications to blockchains. And then, as I mentioned, you have these layer 2 solutions and different sort of scaling methods for blockchains to reduce cost and improve the types of applications you can run. However, that also reduces security the sort of further away you get from the original layer, or the less in sync your consensus mechanism is. So zero-knowledge proofs help boost the security of those scaling methods themselves. And as mentioned here, that's a big market opportunity we're excited about. Something that's especially relevant now, I think we've all seen the effects of misinformation for the last, probably 5 to 10 years in different ways, and it's going to get only worse with AI. But zero-knowledge proofs, as integrated in sort of media production pipelines, workflows, especially as AI starts to come in and automate a lot more of the sourcing and synthesis of media. We currently we don't really have a good solution for determining the legitimacy of information. I think politically, politicians just call out that something is misinformation without really proving that it is, in a way. And we're sort of trending towards more of a censor-based society for fear of misinformation. I've seen some interesting applications in a friend who's building an AI agent that sort of pulls from a lot of different databases and fact checks different claims. But in the production of media, zero-knowledge proofs can basically be implemented when you are typing, writing, sourcing information. As people start to use AI to source information, if you attach zero-knowledge proofs to each of those steps, you can get a sort of a proof that the correct sources were used, or a proof that no one edited or changed the statistics or data from a source to suit their own needs, right? And with zero-knowledge proofs integrated in media production, there's many different ways you could do it. You can have those checks and balances to understand, like, oh, is it the sources that are wrong that lead to misinformation? Is it the editor and the writing team? Is it the was it a programmatic attack on whatever digital media production company? And so you get both a sort of log of media production, as well as, ideally, there's also, not ideally, there also comes security and privacy with that. So, say there's an attacker on a digital media content production software company, and they see that a specific individual is having a press release written about them. They could potentially, specifically target that individual and target that press release. But with zero-knowledge proofs integrated into that system, you would not be able to see which individuals are attributed with which data, and stuff like that. We'll go through two more and then talk about really how zero-knowledge proofs are used within programs. I've sort of just been saying, oh, they're attached to this or that. There are a couple different ways that they are used, but I think that's the easiest way to think about it. As mentioned before, AI. So it's interesting. There's a lot we don't know about how AI produces and chooses to output certain information. And that has a lot of room for attack vectors, right? From foreign entities, from malicious actors. We are going to start integrating AI into higher stakes areas of society just because the value will be higher than the risks at face value, but there will certainly be risks there. And so how do we mitigate those risks when AI is controlling physical infrastructure, or when AI is involved in healthcare, or when AI is helping to produce media, right, and synthesize media? There is verifiable AI, where you sort of pair AI models and their inferencing with zero-knowledge proofs. And by that cause, you can understand, okay, the prompt I sent was used by the model I requested to output the information I got. So you know that no one has just taken your prompt and said, oh, AI outputted this, and lets you use it without actually paying that cost, or without giving you the service you request. That's a very simple, just, sort of a customer or client security measure. But by running AI models within zero-knowledge proof virtual machines, which we'll get into in a sec, malicious actors have a much weaker ability to directly inject at specific points ways to manipulate the AI. Sentient, who is a big blockchain and AI company, they recently put out a paper that a lot of these AI agents that have become popular are still subject to prompt engineering attacks, where you basically submit what looks like a prompt, but really you're tricking the AI into making a system level change. And with something like a zero-knowledge proof in which an AI model will run, teams are much less able to see the system prompt, the weights of the model used, what models themselves are used within agents, and therefore have a much weaker chance of successfully attacking an agent that may be managing someone's money or business, etc. So that is really on the machine learning front. There's a lot of other things, especially, but my company Nexus, we did a verification of a regression machine learning analysis of breast cancer data from UC Irvine. And so this is what I'm sort of talking about, in how bringing verifiability and zero-knowledge proofs to high-stakes integrations of AI will be beneficial, right? I think there's a lot of fear of AI and fear of how it will be used, justifiably. And so we need to approach adding this to our civilization and our lives in a way that is risk mitigated, right? And so by integrating AI with this type of cryptography into, analyzing healthcare data, we can accelerate the rates of meta-analyses and the rate of analyzing scientific data, and therefore accelerate the rate of science. But we also have a fail-safe to understand, okay, this is a place where the AI messed up and it's not actually the data or the analysis, or this is a place where it is actually the data and analyses and the scientific method that messed up, but not the AI's processing of that. And that will just be very positive for a number of reasons, but improve trust of AI in these high stakes, high impact industries, improve the ability to troubleshoot and improve AI, or simultaneously scientific method. And that's just one example of where sort of verifiable AI and machine learning comes in. But that's also especially interesting. Finally, is sort of verifying security systems. This really refers to sort of cybersecurity as a whole. For big enterprises, supply chain companies, that kind of thing, they have a lot of isolated systems that sort of work sequentially. You might have your software management system in China that's managing sort of the industrial materials, and that has data and information that passes along to the software management system in the freight company, which is transporting materials from China to the US. And then you have another software management system within the US. By running this all within this zero-knowledge proof-based system, you can ensure that every 30 minutes, every week, every day, whatever the time span might be, that you have end-to-end cyber protection. And the traditional means of cybersecurity really tackles these individually, and you don't get that sort of comprehensive end-to-end guarantee that your business is safe from cyber attack. That was a lot, but those are just a few of the broad areas that this can be applied to. Please, again, do hop in with questions or anything like that. But what does Nexus actually do? Well, as mentioned, we sort of have built all of our work on the shoulders of giants, starting with Turing up here, and all the cryptography and computer science giants coming before us. We're very lucky to have Victor Miller, who invented elliptic curve cryptography, which underpins Bitcoin and a number of digital primitives, working with us, and Jens Groth as well, another world-famous cryptographer. But here are the two products that we focus on: the Nexus Zero-Knowledge Virtual Machine 3.0. So when I've been talking about, you can attach a zero-knowledge proof to this system or this software, or you can do this with zero-knowledge proofs, this is the product that you really use. So a virtual machine, again, apologies if this is something you all already know, but a virtual machine is a sort of digital version of a computer that you would spin up if you're using cloud management system or anything like that. You spin up an instance of virtual machine, and it basically acts like a portable physical computer to tap into at any time. You can run any program in that, depending on the capabilities of that virtual machine. We have a zero-knowledge virtual machine, which basically means for any program at all, you can run it within this virtual machine. And for any program at all, you will get a proof of correct output, privacy, security at the end of running that program. So this is why it's very applicable across industries, because any program at all can be run on this and get a proof. It is modular, extensible, highly parallelized, proof-optimized architecture for developers. So really what this means is we've designed it to be as plug and playable as possible, as well as efficient as possible. So we have sort of the system itself has zero-knowledge proofs that are compressed into zero-knowledge proofs that are compressed into zero-knowledge proofs that eventually leaves us with one single zero-knowledge proof to prove whatever has been done across the entire network. And that is really for efficiency. This is our third iteration of this machine, and it's 1,000 times faster than the previous iteration. Yeah, so it's built for RISC-V, which is a widely supported sort of zero-knowledge, or not zero-knowledge, it's a widely supported instruction set, which you can compile from languages like Rust or C++. And thankfully, again, we're seeing great improvements. This version is 1,000 times faster than the previous iteration, and we expect to see a similar development with our next iteration. Go ahead.
Like this is another hot topic, right? That you guys are implementing. Even before it was a hot topic, because Vitalik is actively speaking about using RISC-V into building more scalable building blocks for Ethereum, right?
Yes. Well, we're basically looking to scale Ethereum in as many ways as possible, and RISC-V and zero knowledge virtual machines are a great way to do that. We also have the Nexus Layer-1, which is basically a demonstration of the power of our virtual machine. We see this Layer-1 as being a coordination mechanism for a lot of different businesses and entities. We're looking to partner with other ZKVM teams so that anyone using the Nexus Layer-1 has access to an immense amount of compute power. Remember, we are trying to get as many compute providers as possible. And then they also have access to this verifiability. We envision having multiple rollups that settle on our chain, an ever-expanding suite of computation providers, so we do become that global supercomputer. In fact, we've made it as easy as you basically use a browser-based web app or download an app on your phone, and you can start supplying compute power with your spare hardware and earning rewards from your phone, from your laptop, easy as that. And we just want to keep acquiring more compute power. Yes. Diving into the virtual machine, and I'll try and wrap this up so I can cover a bit more how you guys can look to interact and engage and build with our system. But yeah, this is just some of the core principles. We're using the latest frameworks in zero knowledge and optimized for the existing instruction set RISC-V. And recently we used Starkware, which is a zero knowledge research and development company that Stu Prover. And we'll be looking to integrate a new, even better prover for the next iteration. Core design here allows for efficient proof generation and dynamic memory. And a lot of that is based on this folding and recursion mechanism. We simplify Rust programming. So really, eventually, the power of the ZKVM is that we can basically compile any code from any language. And we have Victor Miller actually working on that. He's building us a pre-compiler. But right now, it is a Rust-based programming system. But we will be able to support Python, Solidity, whatever else it is.
So you can run Doom on chain. I've heard that before.
Which one?
Running Doom, the game Doom on chain. That would be super
cool.
cool.
I've seen that from
Cartesi guys. They were doing that, I guess.
I think so. I think they did they do that on Doge?
I don't remember, but because they also have a RISC-V VM and the architecture, right? So everyone here listening to this video, let's come back in a few months and see if we can play Doom on chain on Nexus.
Well, so I mean that could be a great vibe coding exercise. We'll have to see, but I think that application was built and settled on Dogecoin, and we actually had a partnership a while ago to scale Dogecoin with our zero knowledge machine to an L2. So, you know, if you really care about the potential of this technology, you could go and create a whole gaming ecosystem on Dogecoin, settled using our ZKVM.
That's super cool. It's funny to open. Let me just rob a half a minute on you, Alec, because we have 2 submissions in the Action Fund that are about verifiable gaming. So I could be calling these people to build on top of Nexus. That could be a whole theme, verify, not about Doom necessarily, but verify your gaming experiences with the ZK inside the ZKVM. That could be definitely something that will attract people.
I mean, I think the main things I get excited about with ZK powered gaming is interoperability of assets, is sort of premium and long-lasting reward features for you know, OG holders or gamers, and so having, you know, cheap protection also in that regard is big. But yeah, having these vast sort of open market, free market, very interesting economics games sort of like RuneScape, how RuneScape had this whole paradigm for acquiring gold and having this whole real world economy. If you just imagine that, but way, way, way more expansive, that's what blockchain-based games enable, and zero knowledge helps scale those. So you can actually have more of it be fair and settled on chain.
If anyone wants a sample of that, I'm going to drop the link here in the chat. Alec, you check that link to do Arcade Kings. They submitted to the fund, and they are using ZK proofs. They are trying to use actually ZK proof for proving the game side of it. This can be a very fun experiment.
Yeah, I'd love to connect with them, honestly. Just to wrap up quickly, this is just to give a sense of the scale of what we're building. So from our first testnet, we ended up with 1.5 million plus users and nodes, and 100,000 plus simultaneous users running nodes, which ended up giving us several quadrillion flops of computes, which is a huge amount. And our network only gets more powerful with the more nodes joining. So one of our big goals is to basically get as many users and compute providers as possible, reward them for being here, and then support applications developing on our network to service them. And I'll show you all how to run a node and start earning rewards after this. But yeah, that's all stuff we talked about. We have the distributed compute network, basically these node providers. You send or you build an application on Nexus L1 or any affiliated L1, L2. That request or that interaction and the application itself will be run by a number of different nodes along the world. And then the blockchain network here is what provides the decentralized fairness and trustlessness that, okay, these nodes are not manipulating my experience, my interaction, and therefore I'm willing to interact with economic capital on this network. This is all stuff that may not be as interesting for you guys, but different reasons why this network is different, more suited to scalability, privacy, etc. But yeah, I think overall you get more trust and transparency. A lot of chains these days are centralized and people are worried about that. And we see repeat phenomena of centralization leading to scams, foul play, etc., in this space. So I think working towards enhanced trust and transparency is always beneficial. This off-chain computation is big because a lot of the principles here forego efficiency in computation, and zero-knowledge proofs sort of bridge that gap. They bring back the ability to run complex programs. We get data privacy, which is beautiful. We're actually looking at working with a couple teams to have AI models that are trained on user-provided data, but that data is kept private and also attributed to the user. So you basically can select which information about you would like to provide for training. The AI model and the owners and the subsequent users never know what that data was, and you get paid for every subsequent use of AI, of that model. So that's super exciting, I think, and super empowering and liberating for the world. And then, of course, new forms of smart contracts. Basically just expanded types of contracts. Again, smart contracts traditionally have been very limited for a number of reasons. Finally, wrapping up, this is our team. I'm very proud to work with this team. We have some amazing, incredibly smart people. Daniel is only my age, but he's it seems years and years ahead of anyone I've ever met. 2 times international physics Olympiad medalist, CS at Stanford, etc. Jens Groth, Alex Fowler, Diego Prats, Lauren Dresnick, etc. All great people. You can see great names here. I'm very proud to be working with this team. And then, of course, just some amazing cryptographic talent here. So yeah, that's sort of the basics. Here are some initial ways to get involved. On the left, you see run a node. That should lead you to Nexus OS, which is currently you can just, I turn it on when I work. It will, we have this developer net going right now with a little bit of limited activity, but you earn points rewards, which will lead to something more tangible later, but our that's sort of our reward system at the moment. In the future, we actually just released a new globe view of all the nodes in our network, so you might want to check that out. It looks pretty nice. In the future, we're going to have an app store, trading experience, etc., all in that application. So think the everything app, web, a social feed, etc. If you're a developer or budding developer, you can check out our docs with the QR code in the middle. I think I'll touch on what the best things are to develop right now. So I would say right now we have our developer net live. If you are an experienced developer, particularly if you have some blockchain development experience, give it a go. Please reach out to me. I'm in the Venture Miner Academy chat. Matheus will share my contact information. Let me know how I can best support you, and if you have questions. Very excited with launching the mainnet in sort of Q3. So it's a great time to a couple of different months to basically try and develop something, and then get the launch support that we will have, and distribution to our 1 million plus users on launch. So I think it's definitely worth exploring. For vibe coders specifically, what I would say is focus on creating an app that you think is fun and interesting, and that you would want to put in the hands of, again, 1 million plus people across the world, because that is what working with us will facilitate for you. If you have an app that is fun and interesting and has some economical payments or AI component, that perhaps you've seen a lot about crypto and you're inspired by something and want to integrate some kind of, again, payments, AI, or sort of economic incentive component, focus on the app experience, the user experience, creating a nice front end, etc. I think that's the easiest thing to do as a vibe coder, and then talk to us, and we can easily sort of connect it and settle it onto the Nexus L1. That for me is the best advice I can give at the moment, because I'm a budding vibe coder in training, and I don't think many AI models really have the smart contract expertise you would want or need to get super deep into like building a protocol. This space needs more fun, social, and just fun apps for people to use. There are a couple teams we're working with which have sort of prompt-based smart contract development tools, which is quite cool. So you would be able to say, hey, make me an NFT launchpad for cats and cat lovers, and 50% of all proceeds go to a cat charity. And then this partner that we're working with, their program would be able to spin that up for you right away. So that is interesting to check out. That's not live yet, so I just recommend following Nexus on Twitter, at Nexus_labs. I'll put that in the chat here. And then finally, if you have some AI talent, if you're interested in what I've been talking about, we are hiring. We're hiring for a number of positions, both developer focused and non-developer focused. So yeah, if you are considering that, reach out to me, because I have a referral code, and be happy to share that with any of you. But yeah, I think the best, if you're curious, check out the website, nexus.xyz. Follow the Twitter, try out running a node. And yeah, I mean, if you're here, you're clearly interested in decentralized systems, AI, building something yourself. I think there are more than enough resources to support people with good ideas who are not necessarily building for this sort of, cyclical, Ponzi-nomic, whatever vibe that often gets focused on in Web3. So I think coming with a first principles creative approach, building an app that you would build for the regular internet, and then integrating some of the beneficial components of Web3 and AI, that is how you're going to set yourself up for the best success. And that is exactly what the space is looking for. That's what we're looking to support, and would be very happy and willing to support with marketing, partnership introductions, investor introductions, et cetera, et cetera. So yeah, now is a great time to build, because you have several months until we launch. And all
That's
thanks
wonderful.
to Matheus for encouraging this all the time. But
That's
yeah,
wonderful.
I think that's me. Any questions? Anything you think I should touch on, Matheus?
No, that's great. Just to set up expectations. So one of the big complaints that we have when people trying to deploy vibe coded stuff into Web3 is the complexity of like Solidity, the EVM, every time they want to deploy, and that's kind of a deal breaker for a lot of vibe
Yeah.
coders, especially the non-technical trying to build something. It's super easy to connect a database, connect Stripe, payments, and all. Why should we struggle too much to learn Web3, right?
Yeah.
This seems like a solution. It seems like
Yep.
a building for the normal Web2 ecosystem, still with the Web3 verifiability
I would
and
say,
security factor, right?
I would say that as it is right now with this developer net, it's definitely not that utopian end vision of where anyone can build anything and deploy it. You definitely still have to know Web3 primitives. It will be difficult to vibe code. However, for our this is why I said focus on like the front end and like all the Web2 primitives, because for our launch, we are going to be working with some of the best developer tooling companies in the business, who basically make it as easy as just calling an API to create or interact with Web3 primitives. And in that sense, then it's much, much easier because, you know, all sort of AI programs now will instruct you on how to integrate APIs and interact with them. So, yeah, good point. Fair warning. I think it's always worth trying, though.
Yeah, it's a path, but it's good to set up expectations.
Yes, yeah, good point. Any other questions or comments? I'm just checking the chat.
Yeah, do you have the link for that hiring QR code?
Oh,
Maybe paste you in the chat. I'm going to.
I will paste it in the chat. Let me see here. It's also on
You
our
need people in
website.
SF, right?
Yes, it's in SF, but yeah, I mean, it's primarily San Francisco, but we, you know, for exceptional people, I think we're always willing to expand that.
Nice. Have some good community in other places. New York, some very good people in Denver too. A lot of community in Europe. This is kind of late for the Europe time zone, but you're going to watch the recording later.
Appreciate you signing on, Alex, because and whoever else is in Europe, because I know it must be late. But thank you for your time. Appreciate it. I hope that was a suitable level for everyone. At the very least, I hope inspired more curiosity. I just think it's cool that you can sort of, it's based on foundations from war, right? And sort of coding and decoding messages, and then, you know, it's something we haven't yet implemented in the internet, and that's why we have a lot of problems. So it's very cool to me, despite not being, you know, super technical myself. So hope to inspire you all and yeah, work with us, because we're going to launch. And oh, thank you, Imtiaz and Alex. Please do reach out to me. I will add my LinkedIn and Telegram in the chat. Always happy to help and support people who are building, and yeah, direct you to resources.
Imitiaz, I guess it's SF based, right? Or New York? I can't recall properly.
Who, me? Oh, Imtiaz.
Imitiaz. New York based. Yeah.
I just moved from there.
Yeah.
Joined Nexus, actually.
Nice.
Thank you.
Oh yeah, Imitiaz was there while you were giving the talk on the February. That's good.
I'm gonna blush. That's hilarious.
That's good.
Please do reach out then. Appreciate that. And I think, as I said last time, there are plenty of resources. Companies with too much money and not enough applications for real people. So yeah, I mean, it's a great opportunity for all of you.
Wonderful.
But yeah, thank you, Matheus. As always, please do share the recording with me as well. And yeah.
That was a wonderful introduction. The best 2 minutes introductions on ZK that you did. That first slide was great, and then you showed how Nexus is delivering. I don't know for everyone there. Maybe we're going to have a lot of comments later of people watching the recording, but I guess we could slice some fragments of this and
Yeah.
put like the cities and get it started with ZK. That could be a good one.
Well,
too.
that would get any content like that will get reposts and amplification for sure.
Let's do that. That's great. Thank you everyone for joining. Thanks, Alec. We're going to see a bunch of submissions now on with ZK, and now we can get the best projects there on Nexus too. And we keep on doing all the activations like this with the community. Thank you very much.
Love this community. Thanks, guys, for showing up. Means a lot. And yeah, please do reach out. All right. See you, everyone.
Thank you. Bye. Let me stop recording here.